Hello, everyone. Welcome to the concept of deep Q networks. Before we dive into deep Q networks, we shall give you an introduction into what is reinforcement learning. Reinforcement learning is how agents learn to make optimal decisions through interaction and feedback in dynamic environments. One very good example would be chess, the game, where one move feeds off the opposite person's move. So this is how agents will be responding in reinforcement learning. Based on the feedback they are getting, they will learn to make the optimal decision through the reward they are getting, and which is also a kind of feedback. And it is usually applied in dynamic environments. A basic reinforcement learning algorithm would be Q learning. What is Q learning? It's a powerful algorithm in reinforcement learning where a Q table is created. And the rows of the Q table would represent the possible states of the environment, and the columns would be the rewards yielded by the action in the environment. The agent would interact with the environment and record the reward values in the Q table. Eventually, the agent would have filled in the table. The agent could then pick the action with the highest reward value when faced with the environment. So this is how it works. It converts the environment state into a numerical data, and then the convolutional neural network takes in the state input, and the output is the action values for the possible action. Like I said, the reward. And then it stores these experiences, the state, the action, the reward, the next state in a buffer. And then out of this, the sample experiences, it updates the network weights, minimizing the loss. So to visualize this whole process, here is a graph showing us the optimal action value function mapping states to expected future rewards. And then we have an experience replay. This technique decorrelates sequential experiences, which means whatever correlations we thought were valid in the previous experiment may not be in the next. Because as we try to optimize the process of learning through the AI agent, we are decorrelating the sequential experiences by storing them in a buffer randomly sampled for network updates to stabilize learning. So these are the deep Q learning network working principles. Balancing greedy action selection with stochastic exploration. And separating network stabilizes learning. Separate network stabilizes learning, periodically updated from main network. And it's an iterative process. It repeats steps to gather experiences, update the network weights, and refine the policy until finally there's a convergence of optimality, the convergence or optimality of solution. The key components of reinforcement learning, like we discussed, are agent, the decision maker that performs the actions, and the environment, the system where the agent operates. It's the training of an agent to make decisions in an environment. An agent is deployed in an environment. At any given frame, the agent must use data from the environment to act. This action will yield a reward value, which represents the quality of the action. The agent will then accordingly update its process to maximize this reward. I'm giving you a simple example here, an example of how this robot navigates a maze to find the diamond while trying to avoid the fire. So it receives rewards for the correct moves and penalties for wrong paths, somewhat like Pac-Man in the past, the video game. Through exploration and feedback, the robot adjusts its behavior to find the optimal path with the highest cumulative reward. Here is a high-level architectural diagram of how a deep Q-learning network works. Like we discussed, the agent is deployed in an environment, and then based on the action, there's a reward, and based on the reward it again gets trained in the neural network for optimal efficiency. So this is a high-level introduction to reinforcement learning and deep Q learning networks. Thank you.